Welcome to Training My Hobby show. In this show, we are going to discuss basic or preliminary vocabulary someone who are excited to kickstart their data engineering journey should be aware of. I am personally interested to share my experiences. If you are excited, watch this video.
Training My Hobby is all about seeking and sharing knowledge.
Welcome back. As I mentioned in my introduction, this presentation is all about developing the basic data vocabulary to kickstart your data engineering journey. This is just intended as a preliminary knowledge, and everyone will have their own views. Whatever views I am sharing in this video are based on my past experiences as a data engineer, and while designing data engineering related, data management related workflows, or discussing with the customer on data management, what I felt I should know as a data engineer, I'm sharing to you all. Let us start. Before I start, one more important thing. If you're already data engineer who have built a lot of data management workflows like EDW workflows or data lake or analytical sandbox or any other data management components or executed the workflows, this presentation may not be for you. I wouldn't have covered all the vocabulary related to data engineering work, I admit it, because my intention is not to cover every aspect. This is just my intention is to be this video to be very short, preliminary, and want to be as a Kickstarter. That is my intention. Let us start. The way I designed this presentation is into three aspects. Point number one, if you see here, I assume you are a software engineer. You know how enterprise applications work, whether it's a web application, iPhone application, or a middleware, or a backend. You are aware of, or at least aware or have strong experience in Java, Python, .NET, PHP, or it could be any Selenium, any programming language, software programming language. You have awareness about databases or experience in databases like Postgres, SQL Server, MySQL, Oracle, Oracle. And you should know what is a CRUD, create, read, update, delete. With that point assumption, let us start the journey. This video, intention of this video is to bring that basic vocabulary. In the ocean of knowledge, as very huge, the concept related to data management, it's a big ocean. For you as a preliminary, there are four important things which I feel you should be aware of as a preliminary step. The first is basic and emerging words. What are those basic and emerging words? Second, how data flows in an enterprise. Third, understanding of words which are more related to data management. And fourth, but not the least, how to build thoughts when you are discussing with the customer about data management. I'll take a simple discussion between a client and you as a data engineer, and when the client is talking to you, how to build the thoughts as a data engineer. So this video covers these 4 points. Starting with point number 1, which is basic and emerging words. Data and information. You as a data engineer should know the subtle difference between what is data and what is information. I will pause for some time. You think about it, what is the difference between that? And then I'll move into the next slide. I'm assuming you already have the thought. Otherwise, it's very important to know what is the difference between data and information. Data is simply facts. If you go to any grocery store, if you go to Walmart, if you go to Costco, or if you go to any grocery store, you get a receipt. It is a data. The items which you bought, the unit price, the quantity, the discount you got, the benefits you got, all that is the data. So data is all about raw facts, numbers and text. Now, once you put the data into an Excel sheet or any other data analysis tool, then it becomes an information. Why you put in Excel sheet or any data analysis tool? Maybe you want to classify the data. How you want to classify the data? If my receipt is say $300, oh, how come this every month I have only $100? How come this month is $300? Oh, it is a Thanksgiving Day event purchase. That's why the receipt cost is or the total bill is too high, or it is some other festival time. That's why, or some other family get together time. That's why the cost is the receipt cost is very high, or the receipt bill is very high. So you want to classify with the context. Then after class, you could classify it, or you want to summarize it. The summary could be, if you have a set of receipts collected together for say a couple of months, say for a quarter, 3 months, and then you can summarize it saying that like, oh, do you know what? This is the item which I buy regularly, and this is the price change, or this is the total summary. So basically, you want to analyze the patterns like that. So my friends, in a nutshell, I want to say that like you should know the difference between the data and information. Once you have a good understanding of these two words, then comes the information life cycle. You should know the information life cycle. You should build up in your thoughts, starting with A, that you should know how to discover the data, maybe as discover the data or create the data, and then B, classify the data. Once you classify the data, either you may archive it or retire it. Archive it because you already done with its analysis, you got the enough information from that raw data, and then you want to archive it maybe for a couple of years later to use it, or you retire it because the product is no more available if it's a personal use, or if it's an enterprise, the structure of the data has changed. Certainly, once you build the information, you like to secure and encrypt it, and you want to retain it for some time, or you want to hold it. So basically, what I want to say is, I don't want to go through every point. I like to, what I want to share here is, you as a data engineer should know data, information, and information lifecycle. Let's proceed. Then comes define complexity. You might be thinking, what? Data engineer journey, why Kishore is talking about complexity? My friends, I asked before I come to know the real meaning of this long time back, or recently or in the past, I asked most of my friends who are software engineers, define complexity. When I started my career, I understand what is the word complexity. But when my manager said, hey, your code is so complex, I was not able to translate, maybe my weakness, but I've seen many people have not able to translate the word complexity into something else. So I'll pause for some time and see and ask you to look into what is complexity. Yes. The word complexity, you as a software engineer, is a measure of the interactions of various elements. You as a software engineer, software developer, you build independent modules or independent components. And then you interact these components or these modules. Now, if you are interacting more modules or more components, then in the context of the problem you are saving, that interaction might be complex, which is acceptable or not acceptable. I'm not saying complexity is a severe thing. It's very important to know that what is complexity. Then I left it to you whether it is severe or not severe. Suppose say you have developed independent components called function A, function B, function C, function D, and they are interacting and there is a database. As mentioned here, software engineer, for a software engineer, complexity is all about measure of the interactions. You might be wondering, in what way as a data engineer I need to know the complexity? Very simple. When I am designing a data warehouse workflow or a data lake ingestion workflow or data transformation or any other data management workflow using Hadoop technologies like a Scoop, Hive, Pig, or using any other Informatica tool or any other tool, When I want to communicate to the client or to the other team, to my other team members, how many interactions I need to do in that workflow, data management workflow, to take the input, process it, and then generate the output. I should have the good inherent meaning of what is complexity. That's the reason why I feel that like you should have the good understanding of the word what is complexity. Let's proceed. By the way, this word complexity meaning is taken from Wikipedia, so that's why I put the link there. If you want to study more, you can go and look into that. As you've seen, we have seen data and information, complexity, then comes effective and efficiency. These are the two words I personally observed. So many get either confused or or misuse it so many times, either in their communication or they're studying any product specifications. I'll pause for some time and I'll ask you to just get review of what is effective and what is efficiency. Let us see, when I actually searched for effectiveness and efficiency, this is a very good article. I strongly recommend you. But when I Google for effective and efficiency, this is what I got. If you look into actually the word effective, it's more importantly desired or intended. If I ask what is 2 plus 2, it's quite obvious it is 4, right? That is desired or that is intended, right? But if I say 2 plus 2 is equal to 3, then that is not desired output. So you as a software engineer, especially as a data engineer, if you have built any data management workflow or any other data management function, if it is a Hive UDF or it is a pig custom UDF functions, user defined functions, if you have built any function where you take x comma y, and if it is not outputting the desired, then the solution is not effective. If the solution is not effective, what is the useful of that function if it is performed very well? So what I learned is, if something is efficient, inherently it is effective. If it is not effective, then it is not even though it is efficient, it's of no use. That's what, if you see technical, is if you see the technical meaning of useful work performed by total energy. If whatever work you are performing is not generating the desired output, then what is the use of that efficiency? So, my friends, you should have the subtle difference between effective and efficiency. Why, you may ask me a question, why I should know as a data engineer these two words? You as a data engineer, one of the job activity is evaluating so many open source projects or open source products or third party commercial products. So when you are evaluating it, or when you're designing your own solution using any other tool, it need not be data management, it could be any web application development itself. Since the focus of this presentation is about data engineering, right? So I'm talking about data engineering related data management workflow. So I would have developed a effective solution, but it is not delivering it by end of the day. Say for example, if you're building enterprise data warehouse, you need to take the data by end of the day, build a facts and dimensions, and store it into the data warehouse MPP database like Greenplum or any other Teradata kind of a databases, right? So it needs to be efficient. The solution needs to be efficient. So I'll not take it further, but I hope that like you got the difference between effective and efficiency. Let's proceed. This is another emerging word that is coming up called hot, warm, and cold data. Unlike other English words, I'm not going to pause here. Instead, I will proceed further. Okay, so hot, warm, and cold data. Right? So let us first look into what is hot data, what is warm data, what is cold data. Before I go into discussing about it, my friends, it's very, very important to have the feeling or meaning of these three words. It's very important. What is hot data? Hot data could be two scenarios. One, a newly generated data which is hot. Just when you go to restaurant, it's a hot food, it's just cooked. That could be hot data. Or a data that is not generated now, but it is frequently or accessed. Like every nanosecond, many people are accessing it, frequently accessed. One example could be, suppose if there's a sports game that is going on, then the summary of the sport, like what is happening, what is the current status of the game, that is a hot data, frequently accessed. Then what is the next frequently accessed? If I continue the same example of live sports game, suppose I take cricket. What is the current score? Who is bowling now? Who is batting now? It's a hot data. If someone has batted and suppose say in the first innings, and now the second innings is going on, then you least frequently access the first innings data, right? Because you want to know. So that's why it is called warm data. It is accessed, but not as frequent as the latest score. Then what is cold data? Cold data is, suppose you have a player, that player could be like an experienced player or a newbie and just joined the team. So you want to know the player history. It's very rarely accessed data because you generally don't go and look into a player history if the player is a prominent player, right? You just want to know what is the score the player, what is the current score of the player. So this is one example. This could be one. Let me take to a real enterprise data example. Say for example, if there's a large enterprise wherein this quarter data, what are the sales for this quarter data, could be a frequently accessed data. What is the data in the previous quarter? What is the data for sales? What is the sales for this year? Is less frequently accessed data, right? Because if I want to know the performance, if I'm a salesperson, if I want to know performance, how I'm performing, or if I'm a salesperson, if I want to know how much sales I did with a certain particular customer, then I may not access it frequently, but I need to know so that like I can do some more better business with the customer. What is the rarely accessed data? Rarely accessed data, if you take for example, every large enterprises, I think there is a regulation that like you need to maintain last 7 years or 10 years of the data, right? So every last 7 years of the day of if I take a particular example, last 7 years of the data, you can consider it as like a rarely accessed data. It is useful. You cannot archive it. You cannot retire it, right? But it need not be accessed immediately as fast. Why do we need all these three? What is the use of these three different words? As I mentioned here, the goal of good engineering is to optimize both cost and performance. As you can see, the hot data is frequently accessed. You want to store it in such a memory location or a storage location where the performance of accessing it is very fast. Similarly, warm data and cold data. Say for example, to give an example, if I have AWS, Amazon Web Service, AWS storage, maybe as you know in AWS there are three storages are there, S3 and as well as Glacier, and then the Kinesis and other databases are there like Redshift, right, and DynamoDB, all different databases are there. Suppose say I want to frequently access the data very fast. Maybe I will store it in DynamoDB or any other in-memory database like say Memcache, like that. So I'll store it because I want a better performance. Warm data, maybe I'll store it in DynamoDB or Redshift if it is analytical data, and then because it's less frequently accessed. What is cold data? Maybe I'll store it in a Glacier. My examples may not be prominent. What I want to intend here is that you should have the understanding of hot, warm and cold data, I assume. So here the example here is, what is this temperature? It is also called data temperature. Nowadays they also call it data temperature. So if the access pattern is 100% or 90%, if the particular data is 100% or 90% or kind of 80% access, 80% of the time the data is accessed, then it is hard data. Let me jump in next slide and I give a couple of examples there. Generally, what might happen is if you're developing a web application or if you're developing an ETL workflows, product code, branch office details, or if it is a banking organization, last 2 hours trade summary, this is the data which is frequently accessed, right? So that's why it's a hard data. What is less frequently accessed data? As I mentioned, that could be last 7 years of the data or any trade feeds older than say 1 month or medical claim records, right? Once a claim is processed, all right, then maybe for this quarter you may not use it frequently, but for any verification purpose you may need it. So that's why it's a warm data. What is rarely accessed data? Say you need to store the data which is older than 7 years for say for next 20 years for various regulations. So you store it somewhere else in a long-term storage like a Glacier if it is in AWS or any other other persistent storage. That's called cold data. I hope you got the difference, right? So I'm done with the first section. So what we learned here is data and information. What is complexity? Which is nothing but number of interactions. Effective and efficiency. Hot versus warm versus cold data. So I hope that these three words are very important you as a data engineer while building the thoughts. Again, this is just a preliminary video, so that's why these concepts are very preliminary in nature but very important. Let's come to how data flows in enterprise, which is my second topic. Once you have the basic understanding of what is hot, warm, cold data, what is the difference between data and information, then how the data flows in an enterprise. I took a very assume there is an enterprise, need not be in one large building, it could be at multiple places. For the sake of this presentation, I have taken only one large enterprise, wherein that enterprise has built web applications or making those services available using mobile phones, or that enterprise has many offices across the globe. Suppose they at multiple locations, not multiple locations, and users are accessing. Suppose say that enterprise has multiple business applications. Each of this circle or diamond I intended to be a business application. What I want to say is for various reasons that particular enterprise has built silo or dedicated business applications to support a particular set of use cases. It's quite obvious, it's quite common that these applications will have their dedicated databases. The cloud here does not mean that they are deployed on the cloud. It could be on the premise, or it could be anywhere, or it could be on the cloud environment itself. What might happen is so again we're discussing about how data flows in enterprise. So first, assume say in my discussion, these customers are generating the data in these business applications or accessing the data, right? This data, now what happens is while this is the front end applications, in the back end, the business users wants to know the patterns or he wants to create some summary. Basically, he wants to know some information about the data. I'm sure you know the difference between data and information. So what will happen is all the data across these business applications is stored at a central storage. Again, this could be one storage location or it could be multiple storage location. Need not be on the cloud always. It could be on the cloud or on the premise, right? So as I mentioned in my initial presentation, in the information life cycle, you always need to think about archiving, retiring it, or retiring it. That's why in section 4 there is archiving or purging it. So for various reasons, based upon the importance of the data, based upon the life of the data, how many years old the data was, how many years old back the data was generated, you archive the data. Then this business users needs to have access all the data to either to generate the reports or to do some analysis, data analysis. right? So that's why, so this is how this may not give the full picture, but you just need to build how the data flows across the enterprise. I hope you got it, right? So there are business applications are there. There's a central storage is there. There's an archiving question is there, and there are business users are there who generate the reports, which is nothing but information, summarizing it or identifying the patterns from a central storage. Now, what I observed here is I recommended this link, this data management reference model to so many of my contacts, to my friends and my colleagues. I feel this is really a good reference model which everyone should master it as a data engineer before starting your real data engineering journey. So I kept that link ready. Let us access it. What is that link? This is the link. So if you actually see this, so there are internal data stores are there, external data stores are there, and then the data is getting acquired, and then there are different data components are there, data delivery platform, data propagation platform. So I'll not go in detail about this. This, if you go to this, go and search for data architecture and go and see the documentation of this data architecture. It is really fantastic. I strongly recommend you all to go and look into that, and I'll put in my video below the link to this image and its documentation. I strongly recommend you all to look into that. Okay, so basically what I want to say is data flows from left to right, and you can see here there is the database technologies are there, metadata repository services are there. Go and look in the documentation, and here you can see here the green color means different, basically integration points, right? And data delivery is like you have a data warehouse, which is a data component, data mart, which is a data component, in memory data component, right? And then you have analytical environment and client and presentation tools, which are data visualization tools, and then it could be any local data stores, right? It's a really good article. I strongly recommend you all to study. Coming back to my presentation, right? Okay, so now, so let us recap 1 and 2. We discussed about data information, complexity, effective versus efficiency, data versus hot versus warm versus cold data, and we also discussed about enterprise data flow, especially how the enterprise goes from business applications to central storage, from central storage to the archive location based upon its importance, or a business users generating the reports. So this is important. Now let's go to the third point. There are certain important data management words are there you as a data engineer should be aware of. Let's proceed. To make you understand, I taken a simple example. Suppose there are 3 systems are there. 1, 2, 3, the 3 systems are there. Quite obvious that like every system will have a RAM, CPU and a disk. Every system has RAM, CPU and disk. And for the sake of this discussion, I assume that like some file server systems also there on all the systems, a common, basically shared file system, right? And a database is also there on all the systems. And there is a client program which is written in any programming language. It could be Java, Python, .NET, or it could be PHP, or it could be anything, a client program written in any language. What this client is, and assume that this client program is some data management process, some client program. So, and this program has access to all these 3 systems which are connected in a network. Assume say this is the setup. I hope you got this setup. Now let us proceed and understand data management words. Eventual consistency. If you really want to understand CAP theorem, if you really want to understand NoSQL databases or any other cloud technologies, right, you should have the good understanding of what is eventual consistency. So what it says is when a client writes data to a connected server, so if this is the client and this arrow mark is assumes a client is writing the data, and this data needs to be, suppose is written to one system. In these 3 systems, written to one system. That data is replicated to systems connected. Now replicated. So that means the same data is copied or replicated across all these three systems. That is how it is designed. These three systems are designed. Now, when this data, when the data is written here, when this data will be written here or here is eventual consistency. After writing to the first system, other systems gets updated with same data after some time. So if I have another client, assumes I have another client who is reading the data, and if that client is connected to either 2 or 3, by the time the second client connected to the system 2 or 3, if this underlying technology used to copy the data between 2 and 3 hasn't completed copying it or replicating it, right? Then this client will not see the data until it is replicated or copied. So eventually, you have to understand, eventually, we will say that, right? So suppose if I'm reading a book, will you complete the book? May not be today, but eventually I will complete it, right? Sometime later I will complete it, but may not be now, immediately. So I'm stressing the word eventually, consistency, right? So eventually data is available in the systems after some time. That's why if you see the lesson here is that these two systems will get the data after some time. I hope you got what is meant by eventual consistency is very important to know if you are a data engineer. Let's move on to second. This is another word which keeps on hearing, shard or sharding, right? So if we actually look into the dictionary meaning of shard, a piece or fragment, it's a piece or a fragment. Suppose if you have a 1 million rows data, 1 million rows, if this, say for example, not 1 million rows, suppose if I have 750 MB of data, single data, this machine is storing 250 MB, this machine is storing 250 MB, different part of the 750 MB. Remember, in the previous eventual consistency, the same data getting replicated. In this sharding, I'm not saying it is not replication. What I want to say is, in the case of sharding, if I have a 750 MB of data, 250 MB of data is getting stored. The first 250 MB of data is getting stored on system 1. The second 250 MB data is getting stored in system 2. The third is getting in system 3. So part of the data. That's why it is called sharding. Now, you as a data engineer need to design in such a way that how this partition should happen. How this 250 MB, which part of 250 MB could be based upon the primary keys. I want all, I'm just giving a hypothetical scenario, okay? All even numbers here, all odd numbers here, all multiples of say prime numbers here, even numbers, odd numbers, and prime numbers. Maybe, is it right or wrong? I'm just giving the thoughts, right? So I'm not saying this is the way, this is the right approach. What I want to say here is, get the feeling of the word shard or sharding, right? So some part, so for example, 750 of the single data is divided into 3 parts based on a shard algorithm. So you develop as an algorithm and store on each system. That is called shard or sharding. I hope you got it. So other words from the data management perspective you should be aware are change data capture. I'm telling you, my friends, if you are from the Java background or any application web development background, which when I moved from strong Java web application development or middleware development into data management, change data capture was something new to me. It's a simple English word, but it is not a common word used by by web application developers. If you're already aware of that as a Java web application developer, then great. But at least I know people whom I work with who transitioned from a Java, strong Java development background to data engineering, data management development, change data capture was something new to them. It has its own characteristics. Then enterprise metadata repository, EMR. So if you go to this one, metadata repository, if we can see here, metadata repository, basically storing a metadata about all the data information as well as the data stores which you have. across. That's why, since it is across, that's why it's full, it is there across. That's why it's enterprise data metadata repository, right? And then enterprise data warehouse, which is common. These are the another data management words we should be aware of that. But one important thing which I like to bring it up here is, it's very important to know what is data analysis. I'm not saying data analytics, I'm saying data analysis. As you can see, data analytics or data analytics is a process of inspecting, cleansing, inspect the data, cleanse the data, transform the data. I'll give an transform data and modeling the data with the goal of discovering useful information. See here, there is a data and there is an information, right? So this is the raw data, which is just text and numbers, and information, which is a summary, patterns, suggesting conclusions, supporting decision making. So it's very important to know what is data analysis or data analytics, you as a data engineer, so that when the client is discussing with you, you know what are the steps. In what way this is helpful? Suppose say you're asked to create a work breakdown structure of a data analytics work. I'm not saying this is the way, but what I want to say here is, you get some thoughts. Oh, data analytics generally contains inspecting the data, cleansing the data. So you can put that as the top level work level items, and then you can create subtasks under that. So it's very important to know. So summary of 1, 2, and 3. So we learned about some core words. We understood the enterprise data flow, and we also learned about the core words like eventual consistency, sharding, and data analytics. Right? Now comes to the fourth. Before going to the fourth, what I want to say is, the intent of this fourth category here is this. Assume, say, you are a data engineer and you are discussing with your client, and at the back, and you as data engineer has good understanding of data, of all these words, concepts, and technologies, say data information, what is complexity, and everything. Now let us build how we should think by assuming suppose there is a conversation happening between your client and you, and I'm going to show to you how the conversation is going to be. So what are the thoughts you should build at the back of your mind while discussing with the client, if you have the good understanding of this preliminary vocabulary? Client is saying that we have our customers producing data and also some processor data. So that means what is talking about? Data, because producing data, raw data. Also some processor data, that means some information has been built. So that means he's talking about data and information. Remember that you should know about information data life cycle. Second, about data is managed, that means CRUD, by many independent business systems or applications across the enterprise. That means it's talking about enterprise data flow. That means the customers are accessing the data, and there are multiple business applications are there with the dedicated databases, and there is a central storage, and then there is an archiving location, and there are business users are there who wants to generate information like that. So that's why you should know about enterprise data flow. For the given user input, each of our business process goes through various checks before storing the data or generating process data. If you see here, the most important thing is goes through various checks. So that means interactions between the components, which is, as a software engineering, we learned complexity, right? So there is that means those business processes are going through a lot of complexity. I never said complexity is a severe thing. Is not a severe thing. You need to understand the complexity is nothing but interactions between multiple things. We have a lot of historical data and new generated large volume of new data. Some systems require last 7 to 10 years of data. So if some systems require last 7 to 10 years of data, that means sometimes those systems needs to access the data. It is not rarely used. It is least frequently used, right? That means it is a warm data. So hot data warm data and cold data. We need to build a solution that stores our customer data right. What is right? Which is effective. If you say 2 plus 2 is equal to 4, it has the, if you write a function, it needs to return a value of 4. It needs to be effective. That way it needs to data right. If you're not, so as we read in the data analysis, if you are taking the raw data and doing cleansing or data transformation, and if you are not doing data transformation right, if you are not cleaning it right, then your output which you are generating is not effective, right? Processors are fast to generate insights. That means they are looking for some efficient solution. Because you developed a data management workflow which is effective, now they're looking for efficiency, right? So to conclude, what I want to say here, my friends, here is that if you really, you as a data engineer wants to kickstart your journey, this is the summary of the preliminary data vocabulary which you should be aware of. First, these are the things. Second, enterprise data flow. Third, which I said is eventual consistency. Then sharding. This is all the things. So my friends, this is all about preliminary basic data vocabulary if you really want to start your journey as a data engineer.